Hello. Um, my name is Jose Valentino Dones, and I will be presenting the 10 hallmarks of cancer, a crash course on cancer and why smoking is bad. So, smoking any sort of substance can affect an individual's lungs. Today, it has become a trend among many social, ethnic, and age groups. Smoking tobacco among the elder, um, also smoking marijuana among the young adults, and the use of vape among teenagers. It has become a trend to fit into social groups, to fit into society, or to make a statement. But all these substances are also known to be somehow addictive. With the increase of smoking among the population, higher cases of lung disease come along like cancer. Um, an example of how social media and society treats smoking today is this, like Snoop Dogg and the Jimmy Kimmel Tonight Show.
And by the way, Willie Nelson is the only person who's ever outsmoked Snoop Dogg. I believe that. I had to hit the timeout button.
And so, yeah. Okay. So, what does smoking have to do with cancer? Once you start smoking, the smoke irritates the cells in your lungs that connect to your circulatory system. Um, it irritates it and it damages it. It damage our it damages our airway sacs, which is um, basically tissue composed of simple squamous epithelia. And today alone in the US, up to 20% of smokers develop lung cancer at some point. Since the introduction of tobacco in European societies back in the 1500s, many individuals have become ill with a sort of respiratory infection or sickness. Going back to that era, no one knew it was invasive, or um, no one knew it would affect our organs. But people had the speculation it was harmful. In Britain, back in 1604, King James VI wrote a counterblast on tobacco, arguing that smoking was dangerous to lung health and offensive to our senses. Many years of research has proven that smoking or exposing your lungs to huge amounts of smoke can have health consequences. Today, even a bigger percent of the population smokes and has become so normalized, which is bad. Um, so yeah, I wanted to focus my cancer biology project on acknowledging the fact that our society has normalized smoking, and it's bad. So whenever you find yourself smoking, think about where the smoke travels to. It can lead to your lungs, um, looking like this someday if you smoke a lot, and comparing a smoker's pair of lungs with a healthy pair of lungs. It's right here. Uh, but why and how? Smoke. Again, smoke enters your lungs and into the bloodstream through the alveoli, which are made of simple layer of cell tissue that applies a lot of stress to your simple squamous layer of cells, damaging your DNA and pathways within the cell and mechanism needed to divide. So we can start with this image over here, which resembles um, simple squamous epithelium all throughout. And once your cells are exposed to stress or UV light, um, they start resisting cell death and evading growth suppressors. The role of growth suppressors and the role of growth um, The role of growth suppressors is to negatively regulate proliferation, which means cell division and production of new cells in your body. This is to prevent cellular growth and division. These genes involve P53 or T53 retinoblastoma 1 and transforming growth factor beta. In tumor cells, these are activated, so these can control the suppression of growth or um, or the production of more cells, which would allow the tumor to expand. So P53 arrests in cells in the face of mitosis, which is one of the phases of cell production, until DNA is checked for errors or repair of any damage that could have been a result of stress or UV rays. Um, this also blocks cells between the G1 and S phase, which is just another phase of the cell production. And this regulates the function of cyclin. Cyclin is a kinase, which, if you think about it, it could be thought of as an Uber that delivers a person to its job, where it will work towards the production of more cells. Um, so yeah, the evasion of growth suppression would lead to the uncontrolled production of mutated cells that could become a tumor and make it expand. Resisting cell death. Cell death or controlled cell death is regulated by a fine balance between pro-apoptotic and anti-apoptotic proteins. So, uh, yeah, avoiding immune destruction. The majority of small tumors are actually destroyed by the innate immune systems, which we are born with and develop. Um, so the tumor cell hasn't doesn't have much opportunity to develop, but with those who have a problem um, with their immune system, it can enlarge due to the unchecked production of new cells because they are able to avoid destruction. This is more common in cases for people with immunocompromised or immunosuppressed individuals, like people with HIV and other viral infections. Another hallmark we're talking about today is enabling replicative immortality. So, to understand this, we would have to explain what telomeres are. Telomeres are like these lids on your chromosomes, and this is because they are found at the end of the chromosomes. And each time there's a production of another cell, there's a new cell. This new cell will have one less cap. That indicates the age of the individual or the chromosome. And yes, chromosomes eventually run out of these lids. However, when it comes to tumor cells have an enzyme called telomerase, which can add more telomeres or lids to the end of the chromosomes, having these tumor cells being alive until removed or the access to blood is cut. And this is how tumor cells are able to stay alive and tumors grow bigger and bigger. Another hallmark is tumor promoting inflammation. So, when it comes to inflammation, which is another result of a disease or a viral infection, can cause normal cells to develop proneoplastic mutations and resist to cell death. This allows the overproduction of cells and can become a tumor. Um, Inflammation can also recruit leukocytes, such as neutrophils and macrophages, to the tumor microenvironment. Macrophages then recycle growth factors, which tend to aid in nourishing the tumor. The next hallmark over here is inducing angiogenesis. So, angiogenesis is when the formation of new vessels and tumor cells. And this can be done by releasing two cytokines in the vascular endothelial growth factor, or also known as VEGF, basic fibroblast, or BFGF. So this is actually caused by the blood vessels to grow, by the blood vessels that grow and build into the tumor cells, creating a network of vessels and allowing the tumor to become vascularized. This is how they receive the nutrients to keep proliferating. Uh, the next hallmark would be deregulation of cellular energetics. Um, so tumors undergo this process called aerobic glycolysis, which instead of converting glucose into pyruvate like normal cells would usually do, tumor cells convert glucose into lactate in the presence of oxygen. This is less efficient than normal glycolysis, but this has been compromised for the increased production of GLUT1. This allows tumor cells to take in more glucose from the circulatory system. However, although this is efficient, it also facilitates the biosynthesis of macromolecules. So, undergoing this aerobic glycolysis, they are all able to make more amino acid precursors and nucleic acids, which can help tumor cells to make more daughter cells and help the tumor progress. Um, the next hallmark is activating invasion and metastasis. So, 80 to 90% of cancer related deaths are caused by the metastasis of cancer, which is basically the spread of cancer to other parts of the body or the organ. This means it spreads to not the first tumor, but another one in another part of your body or an organ. This can be passed through our circulatory system and pituitary systems. In this case, from one part of the lung to another part of the lung, and then to other parts of the body. This is caused by the breakdown of cell adhesion, which is what causes the cells to bind together. This degradation of extracellular matrix will allow the tumor cells to invade and break free from the first tumor and increase the motility of chemotoxins and tumor cells. Um, Genome instability and mutation. So, tumor cells are constantly evolving in order to adapt to new surroundings. So, as you will probably be aware, um, these are passed down by your, uh, as you are aware of BCRA and BCRA2, which are genes. Um, these are passed down from your family line, and if you inherit one of these genes, you are a lot more likely to develop breast cancer, but other genes would continuously evolve. Sustaining proliferative signaling. This is our last hallmark, and this is basically um, when tumor cells are able to produce their own growth factors, and they also overexpress receptors to make it more likely for binding and lead to more cell production. Among these, we can see the EGF, BG, BFGF, CXCL8, and CXCR2. In endocrine signaling, they can target themselves, the same uh, cell targets the same cell. And in paracrine signaling, they are able to release factors that affect neighboring cells. And when it comes to endocrine signaling, they release chemicals through their blood vessels and target distant cells that are far away. And so, this is how ultimately smoking affects your lungs. It can happen in a small patch of cell tissue and can spread throughout the lungs into the other lung and to other parts of your body. And that's why smoking is bad. And we should find other alternatives to um, smoking whatever we smoke, like tobacco. There's always chewing, and smoking THC or marijuana. You can always have the option of doing edibles. Um, and that would help you in the long run. And so thank you for listening.